Alright guys, what we're going to be talking about today is the Hertzsprung-Russell diagram, called the HR diagram for short, and it's a way to stars either by a size, temperature, or brightness. Those are the three major categories in this classification system. So Hertzsprung-Russell diagram is actually a graph that illustrates the relationship that exists between average surface temperature of stars and their absolute magnitude, which is how bright they would appear to be if they are all the same distance away. Rather than speak of the brightness of stars, the term luminosity is often used. Luminosity is a measure of how much energy leaves a star in a certain period of time, which impacts its brightness. Alright, so here's the diagram that we're going to be going back to. We got luminosity. We got 10 to the negative 4, 10 to the negative, I think that's 3. That'd make more sense if that was a 2. I think that's a negative 2. And then we got 1, 10 to the 2, 10 to the 4, 10 to the 6, and so on. So what do those numbers mean? 1 is our star, the sun. So if it's less than that, less than 1, then it's dimmer than the sun. If it's greater than 1, then it's brighter than the sun. If it had a luminosity of 10, it would be 10 times brighter. Of 100, which is 10 to the 2, it would be 100 times brighter. And this is like 10,000 and so on. Then on the bottom we've got temperature. Towards the left it's very hot, 40,000 Kelvin. Towards the right it's not as hot relatively. It's 2,500 Kelvin. It's still hot, but not 40,000 hot. We have blue, we've got white, we've got orange and yellows and reds. So right here are the main sequence stars. The majority of stars fall into that category. Their size is medium. And as you can see, the colors change. To the far left it's going to be bluer. That has to do with the temperature. It's very hot. You see a campfire, blue flame is hotter than yellow flame. And that's why we get yellow, and then red is the coolest. And you can have things that are supermassive, like the blue giants or the red supergiants, depending upon how hot they are. And then we got the red giants, are a little bit smaller, massive versus supermassive. And on the other side of the main sequence, we have white dwarfs, which burn very hot, but not very bright, and they're low mass. Main sequence, as you can see, kind of fit through the whole spectrum. There's hot ones, there's cool ones, there's bright ones, there's dim ones. So they got the whole basket in there. So what we're going to do is we're going to answer these questions, and that'll be it for this activity. So the sun. Answer the questions using the above HR diagram. I think sun is supposed to go up here, so that's a typo. What factors affects the color of a star? Well, we kind of went through that. The color of the star is going to be impacted by... Anyone want to type it in? That's right. Oh, here we go. How hot it is, exactly. So what factor affects the color of the star? The temperature, how hot it is. Very hot, blue. Not very hot, red. In between, yellow, orange, maybe some white. Alright. So we'll just write that in. Oh, formatting's terrible. Sorry about that. Heat. What factor affects the luminosity of a star? Luminosity. Any ideas? Okay, we got heat, size, elements, color. age could impact it. Let's see. Basically, yeah, luminosity, there's going to be multiple factors. The two big ones are going to be a combination of size and heat. So if it's large and burning bright, or burning hot, it's going to be a bright star. So, but size on its own is not necessarily going to, actually no, yeah, size on its own is going to, because if you look at all the ones at the top, the biggest factor on luminosity is size, although some that are small are going to be just as luminous. And so to a lesser extent, it's going to be the heat. So the biggest factor is size. Secondary to that is going to be how hot it's burning. And that does have to do with the composition. If it's closer to maybe undergoing a supernova, it's going to be brighter. So a number of factors. We got size, then heat, composition. And they all factor into luminosity. Number 3, what is the approximate surface temperature of the sun? All right, so the sun is right here. Approximate surface. Oh, that's where the sun is. Okay, it didn't copy well. So the sun is actually like right here. We'll just say like that one's the sun. So it's around 5,000. So I'd say around 6-ish thousand, you could say. And that's why when you look at it, it's yellow. It's in that yellow area. We'll just say 6,000 Kelvin. All right, number 4, surface temperature of white dwarf stars. Is the surface temperature of white dwarf stars higher or lower than red supergiants? Surface temperature higher or lower? What would you guys say? Lower. You got it. Lower, lower, lower. Oh, wait a minute. Lower luminosity, but actually white dwarfs are going to be a higher temperature than the red giants. Is that what the question is asking? Is the surface temperature of white dwarf stars higher or lower? It's going to be higher. We don't need this. What is the color of the stars with the highest surface temperature? Blue is correct. So the hottest surface temperature is going to be blue. Again, you do have white dwarfs in there. So if you put white, that would be a okay answer too. I'm just going to put blue. All right, what is the color of the stars with the lowest surface temperature? Red. So those are the red giants. There we go. Ben is on fire today in all these. All right, 7. List the color of the stars from the hottest to coldest. Okay. Blue, white, yellow, orange, red. Hot to coldest. All right, what type of star has a high temperature but low luminosity? High temperature, low luminosity. White dwarf, you got it. All right, what type of star has a high temperature but low luminosity? Wait, let me answer that one.
You just did that one. You put in the white dwarfs for number 8.
I was in deja vu there. All right, white dwarf. Okay, so I skipped number 8. Most stars in the HR diagram are classified as, the central ones, main sequence. Most of them are main sequence. Sorry about that. all of these main sequence. All right, number 10. What type of star has a high temperature and high luminosity? High temperature, high luminosity. I'm going to solve those blue giants. There it is, blue giant. All right, what type of star has a low temperature but high luminosity? Red giant, you got it. Rory's killing it. We call those red supergiants or red giants. Or supergiant, that's right. What type of star has a low temperature and low luminosity? Low temperature, low luminosity. Red. Low temperature, low... Yeah, red giants. Yeah, and main sequence also, yeah. So we could say main sequence. Or wait, what's the question? Main sequence. Red giants. What type of star has a low temperature and low luminosity? Yeah, so red giant main sequence would be acceptable. Or some types of main sequence. Alright, plot stars A through E. Alright, this is not really possible virtually, but let's just go through them together. We've got 20,000 Kelvin and 10 to the 6th luminosity. Let's get this thing out. Alright, so 20,000 Kelvin, 10 to the 6. Top left, 10 to the 6, 20,000. Yeah, we're talking about blue supergiant. Nice. Then we got 20,000 Kelvin, 10 to the negative 2. Looking like the white dwarf range. Bottom left, you got it. And then there's 2,500 Kelvin, 10 to the 6. Top right, red supergiant. And the last one, 4,000 Kelvin, 10 to the 2nd. 4,000 Kelvin, 10 to the 2nd. Bottom right is, well, kind of bottom, yeah, middle right. Main sequence. Actually, I think it's going to be red giant. Is it? Let me forget what it was. 4,000 Kelvin, 10 to the 2nd. 4,000 Kelvin, 10 to the 2nd. That's going to be in the red giant range. All right, and that's the HR diagram. So, yeah, that is that.